Okay, so now the next part. Okay, so what is the molar conductance and dilution? So here we will discuss that the essentially the change of molar conductance with dilution. Okay, see, molar conductance with dilution. What will be the change? Correct. Okay, so yeah, if we recall the expression of molar conductance, okay, so just go back to few slides that what is the expression of molar conductance. Okay, molar conductance is equal to kappa, that is essentially conductivity, into volume, that is essentially or molar volume. Okay, so that is the expression of molar conductance, so we already know. Okay, so use this molar conductance expression, that is lambda m molar conductance is essentially equal to kappa, that is conductivity, into Vm. Vm is essentially or molar volume. Okay, so say that if you increase the sorry, not if you increase, so if you dilute the solution, so this, then essentially what you will do now, you will add some solvent, like essentially in general you will add water, correct? So if you add water, then what happens now, that volume of that particular solution will increase, correct? So if you add more and more water, so then the volume of that particular solution will increase, so essentially your Vm will increase. Okay, so but essentially in just if you go back to the previous slide, what happens now, what is about conductivity with dilution. Now if you add few more water, then the conductivity of that particular solution will decrease, correct? Because the conductivity will decrease with increase in dilution. Okay, so here they are opportunistic term, that if you will dilute that particular solution, then Vm, that is your essentially molar volume, that will increase with dilution. It's pretty obvious that if you add more and more water, then the volume of that particular solution will increase. That is pretty obvious. Okay, but what about na kappa? Kappa is essentially decreased, correct? The conductivity is decreased with dilution. Okay, so in terms of dilution, if you dilute, then what happens about lambda m, that is essentially your molar conductance. Okay, so then we see that with dilution, okay, so the decrease in kappa, the decrease in kappa, that is conductivity, is compensated by the increase in volume. Okay, so that is compensated. So what we will expect now, we will expect that molar conductance will increase with dilution. Okay, because the decrease in kappa conductance is compensated by the increase in volume. So increase in volume Vm has a more value than the decrease in kappa. Okay, so see what happens now. If you write these things, then what can I tell? Use me another color. Now with dilution, we can write with dilution. With dilution, what happens now? With dilution, decrease in kappa is compensated by increase in volume. With dilution, decrease in kappa. Use me another color. With dilution, what happens? Now, my pad. Just now it's fine. So with dilution, what happens now? Decrease in kappa is compensated decrease in kappa, that is conductivity, is compensated compensated by increase in volume. Correct? Okay, so then what will be the consequence? Now that consequence is very simple. That is, I already told you that molar conductance, that is lambda m, molar conductance increases, Cr increases with dilution. Okay, so I repeat the reason that that molar conductance lambda m is essentially equal to kappa into Vm. So what is kappa? Now, kappa is your uh, conduct kappa is your conductivity, and what is lambda v? Now, lambda v is your molar volume. Lambda v is your molar volume. So if you dilute the solution, then essentially that is pretty general that the volume of that solution will increase. So the lambda is sorry, the Vm will increase. But we know that the with the dilution, that conductivity will decrease. Correct. So if the conductivity is decreased, that kappa is decreased, and the volume of that particular solution will increase. So then these two are opposing terms, correct? One is increasing and the other is decreasing. Okay, so then what happens now? It's visible that the decrease in kappa. Okay, so it's visible that the decrease in kappa is compensated. The decrease in kappa is compensated by increase in volume. Correct? The decrease in kappa is compensated by the increase in volume. So okay, then what happens next? The molar conductance will increase with dilution. So if Vm, the increase in volume, is compensated by kappa, then it is pretty obvious that the molar conductance is increases with dilution. Okay, then we see that there is a very very popular graph where we can discuss the concentration, where we decrease the molar conductance versus concentration graph. So see what is the what the graph looks like. Okay, so see, after that I will explain what is essentially behind this graph. Okay, so I will draw it. Okay, so I will discuss it in the next part. Okay, I will discuss in the next part.